Now we bring back an old friend, Ernie the Exponential. It was f of x is equal to x squared times e to the x, and we want to figure out where Ernie is positive with its second derivative and therefore concave up, or negative with its second derivative and therefore concave down. So we need to find that second derivative. In the first part, we found the first derivative using the product rule. It was x squared plus 2x times e to the x. If you want to see why that is, go back to part 1. F double prime, it will also be found using the product rule. The derivative of e to the x, if you'll remember, is just e to the x. So we'll leave this alone, take the derivative of this. We get x squared plus 2x times e to the x. And now we'll take the derivative of the first part times e to the x, which would give us 2x plus 2 e to the x. Combining these and factoring out an e to the x, we end up with e to the x times x squared plus 4x plus 2. So of course the natural question is, how do we find critical points from this? Well, remember that a critical point is wherever the second derivative is equal to 0 or does not exist. There won't be a point like that for our exponential here, so we just need to find out where the second derivative is equal to 0. In this case, we've got f double prime of x equal to e to the x times x squared plus 4x plus 2. This is not easily factored. And remember, e to the x is not equal to 0, by the way. So we resort to our quadratic formula. X is equal to negative 4 plus or minus the square root of 16 minus 4 times 2, all over 2. When you reduce this, the square root of 8 reduces down to 2 root 2. And this reduces down to negative 2 plus or minus root 2. This is going to make for a fun sign test. So let's take a look at that. We've got two critical points, negative 2 minus root 2 and negative 2 plus root 2. Obviously negative 2 is in between the two of them, because here we subtract a positive number, here we add a positive number. When we test negative 2, we're going to get 4 minus 8 plus 2, which is a negative number. E to the x, of course, is always positive. So we get a negative right here. Negative 2 minus root 2, a number less than that might be x is equal to negative 4, because root 2 is less than 2. When we try negative 4, we're going to get 16 minus 16 plus 2, which is a positive number. Remember, e to the x is always going to be positive for real numbers. And a number bigger than negative 2 plus root 2 would be something like x is equal to 0. When we plug that in, we're going to get a positive number here. So the sign test goes positive, negative, positive. And whoops, Mr. Smith needs to make sure that he labels his sign test so we know exactly what we're testing. Therefore, we have a concave up function when x goes from negative infinity to negative 2 minus root 2. And then from negative 2 plus root 2 to infinity, because f double prime is positive. And in between, we're going to be concave down because f double prime is less than 0. That would be the interval negative 2 minus root 2 to negative 2 plus root 2.